Alright, in this video we're going to be going over the ear, structures and functions of the ear. So the ear is divided into three regions. We have the external ear, which is shown here in yellow, and then at the area of the tympanic membrane, part of the external ear, that's a dividing line between the external and the middle ear. And the middle ear is shown here in blue. It has the auditory ossicles. It has this tube that comes down from the throat, or comes up from the throat, called the auditory tube. And what you see here in this beige color is going to be the inner ear, which is going to consist of the cochlea, the vestibule, and the semicircular canals. So let's take each of these regions and talk about the structure and the function. We'll start with the external ear. And the external ear, the large portion that directs sound waves into the external auditory canal, that's called the auricle or the pinna. It's a flap of elastic cartilage. It's covered by skin. It collects and channels sound waves into the external auditory canal so that those can stimulate the tympanic membrane. The lobule is a part that hangs down from the ear. This is what we hang ear rings down from, or some people can put different size gauges until they can put their cell phone in there. Rabbit uses them to certainly collect all kinds of sound. The bigger your ears, the better able you are to collect sound. It also helps to dissipate heat through its ears, through all those blood vessels going through there. It helps to cool off the rabbit. Now the external auditory canal, also called the external auditory meatus, it's about 1 inch long. It lies in the temporal bone here and runs from the auricle into the eardrum. Directs sound waves into the tympanic membrane or eardrum. It's lined by skin containing coarse hairs and specialized sebaceous glands. These sebaceous glands are called ceruminous glands, and they produce earwax. Scientific name for earwax is cerumen. And the hairs in cerumen help prevent dust and foreign objects from entering the ear and slows the growth of microorganisms. Now the tympanic membrane or eardrum, it's a thin, semi-transparent partition, as you can see here, semi-transparent. It's a partition between the external and middle ear. Basically, it transmits sound vibrations that enter the ear to the auditory ossicles, which are these three bones that connect the tympanic membrane to the inner ear, where that sound is going to be transmitted into an electrical signal at the cochlea. If you have a perforated eardrum, as shown here, and certainly be able to reduce your hearing capacity, or if you get inflammation, get it all red. If it's a small enough hole, they can tend to grow back. If it's a large hole, you have to go in there and get a graft done. Now the tympanic cavity is a small air-filled chamber that's located between the eardrum and the inner ear, and it houses the auditory ossicles. The eustachian tube or auditory tube, also called the tympanopharyngeal tube, it connects the middle ear with the upper part of the throat, shown here, and it basically functions to equalize air pressure within the tympanic cavity, so the eardrum doesn't rupture with pressure changes. You can open this up by swallowing or yawning to cause the tube to open. So for example, you've probably gone up in elevation, but when you start going up in elevation, you hear the popping sound as you relieve pressure as you go up in elevation. And basically as you go up in elevation, air pressure is decreasing. You have less gas molecules. So the pressure outside this tympanic membrane is getting less. And then what you have trapped in this middle ear here, as the pressure gets less outside the tympanic membrane, there's less pressure pushing on, well, the air molecules that are in the middle ear, and they begin to expand. As they begin to expand, it puts pressure on the back of the eardrum, which can be painful. So you yawn, chew gum, swallow, and that opens up this auditory tube or eustachian tube, and that pressure, the air pressure that's increasing in this middle ear, gets released, and the eardrum pops back, and you hear a popping sound. And you do that all the way up in elevation to equalize the pressure behind this middle ear. The opposite happens when you come down in elevation. As you come down, the pressure which was less out here, let's say from 5,000 feet, you're coming down in elevation. Well, now the pressure is increasing outside the tympanic membrane. But what you had trapped in here is still the amount of air that you had when you were at 5,000 feet. And so the pressure tends to push in on the eardrum as this gas gets compressed. Well, that causes pain on the eardrum. So what do? You yawn, chew gum, you swallow. It opens up this eustachian tube, and now air can rush in because it has decreased pressure here, so the air is going to rush in to fill that middle ear. And the eardrum pops out. Well, as not popping out of alignment, but it just gives a little pop out because you have air coming in here. That gives you that popping sound as you come down in elevation. And each time you equalize the pressure here in the middle ear. Now the auditory ossicles in the middle ear consists of the malleus, incus, and stapes. 3 bones. The common name for them is malleus is a hammer. Looks like a hammer, like a mallet. Incus means anvil. Looks like here the old anvils people used to work on metal. And the stapes means stirrup. So if you look at the stapes here, it looks like a stirrup. And the stapes is what fits into the membrane-covered oval window. So this window right here has a membrane covering it, and it's oval in shape, so we call it the oval window. Right below it is a round window, also has a membrane over it. And we're going to see that during hearing, the stapes moves in and out, being pushed on by the tympanic membrane through these auditory ossicles, and that pushes on this membrane of the oval window, which starts up pressure waves that move through the cochlea and stimulate these hair cells so you can tell what frequency of sound you're listening to. Here's an enlarged picture of it. Here's the tympanic membrane, malleus, incus, stapes. Stapes in contact with this oval window, and here's the round window. And as this pushes in and out, it's going to start pressure waves that go through the cochlea to stimulate the hair cells. So vibrations of the tympanum convert arriving sound waves into mechanical movements that are transmitted via these auditory ossicles to the oval window. Now there are small muscles that control the amount of movement to prevent damage by excessively loud noises. So the smallest muscle in the body is the stapedius muscle attached to the stapes. You also have this tensor tympani muscle here, and when as sound gets louder and louder, these can contract to dampen the sound to help prevent overstimulation. But on quick loud sounds like gunfire going off, it can damage the ear because these muscles can't respond that quick to help dampen the sound. Now the oval and round window. The oval window, or both are membrane-bound windows. The oval window is between the middle and the inner ear, and it fits, the stapes fits into this. And as this pushes, the fluid is going to move through the cochlea, and although the fluid doesn't come out, it has to have some place to expand or being pushed to. And the round window, which has a membrane, helps that fluid kind of move the round window out. So as you push in here, the round window pushes out. And it goes back and forth, and the round window will go back and forth as this fluid, as waves move through it.